For any linear system, no matter how many equations, no matter how many unknowns, if I want you to use row reduction, if I want you to use the matrix method to solve the system, the first thing you do is to write the augmented matrix. Augmented matrix. It's too easy. I think for all of you guys, it's easy. Anybody want to tell me the first row very quickly? 0, 1, 1, 3 is the first row. The second row, I think, is 1, 1, 3, 8. The third row is 2, 1, 6, 15. This matrix, now let's recall the term. This matrix is called the augmented matrix of the given system of linear equations. I want to put up a bar to separate the coefficients and the constant term. The last column is determined by the constant terms, right? That's the augmented matrix. That's the augmented matrix. Okay. And then look at the step procedures. In here. The next thing we do is to create leading one, to make leading one of row 1. Basically, we want to make this location 1, this location 0. There are many ways we can do, but the simplest way, anybody want to tell me how to make this location 1?
Interchange by row 2.
Yeah, interchange row 1 and row 2. The operations we are performing are elementary row operations. When I talk about changing, you have to use elementary row operations to change the matrix. We use a notation like that. Simran told me to interchange row 1 and row 2. The first step is to make this location 1. To create, I think the wording is to make leading one of row 1. The first row now becomes 1, 1, 3, 8. The second row is 0, 1, 1, 3. The third row is not changed. I think 2, 1, 6, 15. I mentioned the last time, for a matrix, you need to use square brackets. Square brackets in here or here, and here, or round brackets. You have to include brackets. Now I'm going to circle this number. This number is not going to be changed in the whole procedure. We want to perform a list of operations to make the matrix REF in row reduced echelon form. Now look at the second step. This one is to use leading one of row 1 to create zeros at all numbers right below that leading one. So that's the meaning. Okay. What we meant is to use this leading one to make this location 0, to make this location 0. This location is already 0. You do not have to do anything about that. Now the problem is what operation you can perform to make this location 0.
Maybe multiply by 0 to row 3.
No, we cannot multiply a row by a 0. We have to multiply a row by a non-zero number. In most cases, this can be done by performing elementary row operation number 3. Anybody want to write the notation for the operation we are going to perform to make this location 0?
I think maybe by adding -2 in it.
Yeah. So -2 is correct. -2 is correct. I will tell you how to get the multiple. To get the multiple, you think 1 times what number then plus this 2 is equal to 0. I'm going to write it down. Okay. You think that's your brain. You think 1 plus what number then times 2 is equal to 0. I did something wrong. You think 1 times what number and then plus that 2 is equal to 0. That will give you the multiple. So the question mark is -2, right? That will give you the multiple. So the operation we are going to perform is to add -2 multiple of, I'm going to write a longer line. The operation we are going to perform is to add -2 multiple of row 1 to row 2. And then, sorry. So can I try again? I think I got the wrong order. To multiply row 1 by -2, I told you how to get the multiple, right? If we multiply row 1 by -2 and add the multiple to row 3, we want to make this location 0, and then row 3 is changed. Again, the meaning of the notation is the new row 3 becomes the old row 3 times then plus -2 multiples of row 1. Okay. You're going to see how this will work. We wanted this location to be 0. Okay. So row 1 is not changed, so it's 1138. And then row 2 is not changed, 0113. Row 3 is 0. Okay. You have to change other numbers correspondingly. -2 times 1. Now remember the multiple is -2. -2 times 1 is -2 plus this 2 is 0. That's how you get this 0. Okay. -2 times this 1 is -2, and then -2 plus this 1. I think you have -1 in here. And then the multiple is -2. -2 times 3 is -6. Then plus 6, you have 0 here. Is that right? And then -2 times 8, -16. -16 plus this number 15. I think you have -1. Okay. So because that's the first time we are doing this, I'm going to do this row for you. So we are done the first round of step 2. We are done step 2 actually. In step 3, we just repeat what we did in step 2. We repeat for all the rows. Okay. We repeat for all the rows. So basically, in next step, that's going to be the leading one of row 1. The next step is to make leading one of row 1. This location is already 1. We do not have to do that, right? And then what we do is to use this one to make the number below, or the numbers below, zeros. We want to use this one to make this location 0. Anybody want to tell me what to do? So just tell me the multiple. What's the multiple? We add what multiple of row 2 to row 3? Then we can have then we can make this location 0.
Simple addition.
Yeah, multiple of 1. Okay. We just multiply row 2 by 1 and add the multiple to row 3, and then row 3 is changed. Again, I wanted to use the circled number, the leading one of row 2, to make the number below 0. Okay. So basically you think we multiply row 2 by what number, and then add the multiple to row 3 can make that location 0. The multiple is 1. The multiple is 1. So because 1 plus negative 1 is 0 already. Now I will give you a little time to get me the new row 3. Get me the new row 3, please. And then we compare the answer. I want you to do it on your own. So you can compare the answer. I do not want you to copy. So please, I want you to try something. And then after you're done, you can write your new row 3 on the screen. Write your new row 3 on the screen, please. Write your new row 3 on the screen, please. 0012. I think that's right. 0012 is right. At this point, we are done the first round. But still, if you see this number is not 1, you have to make that location 1 first. So before you move on, okay. The resulting matrix is still not in REF yet. It's not REF. And then we go backward. And by the way, in past years, I used to use a different way. Now I realize there's a simpler way to avoid many mistakes. And then we go backward. If you look at the step procedures, we are done step 3. So basically, we made all the numbers below the leading ones zeros. We made all the numbers right below the leading ones zeros, below the leading ones. And then we're going to do step 4. For step 4, we start from the last row. Okay. Start from the last row, and then is it message has a lag? We start from the last row. And then we use the leading one of. You have it on the screen, okay? You have it on the. You have the step procedures on your phone probably. I will tell you the meaning of the next step. I don't even remember the step number. The meaning is we go backward. Start from the leading one of the last row, and then we use this one to make these two locations zeros, and then we go backward. So because that matrix is still not in REF yet, we want to make the whole thing REF. Okay, now we're going to use this one to make this location 1, to make this location 1. When we do this, it's permissible to perform 2 operations in one step. By that I mean, okay, I will tell you what I mean very shortly. But now think, how can we make the circled leading one of row 3 to make this location 0? We want this location to be 0, required by condition 3. So just tell me the multiple. We add the multiple of row 3. We add what multiple of row 3 to row 2? We can make this location 0. Yeah, -1. So -1 is right. You think that leading 1 times what multiple and then plus this 1 is equal to 0? That will give you the multiple, right? 1 times -1 and then plus 1 is equal to 0. So the first operation, one operation we perform is to multiply row 3 by -1 and add the multiple to row 2. And then row 2 is changed. we change row 2. Okay. Our target is to make this location 0. Do not write row 1 yet. Okay. Write from the last row. The last row is 0, 0, 1, 2. Now we work on row 2. We work on row 2. Row 2 is 0, 1. These two numbers are not changed. So because of these two zeros. And then this number is going to be 0. So because 1 times -1 and then plus this one is equal to 0. And then this number times 2 times -1 is -2 plus 3 is equal to -1. It's equal to 1. Sorry, right? 2 times -1 is -2 plus 3 is equal to 1. So this location is going to be 1. I told you it's permissible to perform two operations in one step. Only in this case. Only when we make zeros. When making zeros, it's permissible to perform more than one operation in one step. By that I mean the next operation we are going to perform is to use this one, the leading one of row 3, to make this location 0. So tell me a multiple. So just tell me a multiple. You think 1 times what number and then plus this 3 is equal to 0.
-3.
Yeah, -3 is right. Okay, so the operation we are going to perform is we multiply row 3 by -3 and then we add the multiple to row 1 and then row 1 is changed. Okay, the meaning is we change row 1. The new row 1 becomes the old row 1 plus or minus 3 times row 3. We're going to get the new row 1. The new row 1. This number has to be 0. You have to get all other numbers correspondingly. We wanted this number to be 0. Actually, so these two numbers are not changed. Right. These two numbers are not changed. We wanted to make this location 0. Okay. Anybody want to tell me this number? Yeah, this number is 2, right? I think this number is 2.
+2.
Yeah, this number is 2. So 2 times -3 is -6, and then plus that 8 is 2. We're almost done. So basically, we're almost done. So in one more step, we're going to be done. Again, the second round is to go backward, starting from the leading one of the last row, and then you make zeros. Now we go back to the second row. Okay, this is the leading one of row 2. In next step, we're going to use this leading one to make that location 0. Eventually, we're going to have the matrix in REF. Okay, I will give you 1 minute to try to get me the new matrix. I told you the last thing we do is to make this to use that one to make this location 0. Now I'm looking for the operation you are going to perform. I'm looking for the last matrix. You are going to see the last matrix is going to be in REF. Now I'm thinking about I remember the question Ben asked. For this one, you have to write all the operations and all the middle matrices to show me the work. Okay. Do not give me only the list of the operations. You have to show me work as shown on the screen. Now I want you to work out the last matrix. The last matrix, I still want to write backward. 0, 0, 1, 2. 0, 1, 0, 1. The last matrix, I think 1, 0. This number is probably 0. Sorry, I don't know your question, Karen. In last question, we can only write operation. No, you have to write all the matrices. You have to write all the matrices. I mean, only operations are not efficient, are not surface. I mean, can anybody tell me the last number in the REF? So just tell me the last number in the REF, please.
1.
1. I think 1 is right. Yeah, this number is 1. We were using the second row. I was thinking about something different. Still, I want you to honestly check, is the last matrix in REF? Is the last matrix in REF? I wanted you to check all the 4 conditions before you can get the solution. I'm sorry, I forgot to write the notation for the operation. From here to here, we multiply row 2 by -1, and we add the multiple to row 1, and the row 1 is changed. Yeah, that's good. That's good. That's good, Simran. Okay, is the last matrix in REF? Check all 4 conditions. It's very important to make sure the final form is in REF, is in row reduced echelon form, before we get the solution to the system. Okay? You check all the 4 conditions. I believe the last matrix is in REF. All the 4 conditions are satisfied. Okay? Good. We say it is in REF. It is in row reduced echelon form. Something is in some form. So that makes sense? Okay. Now the whole picture. You have a system. You're given a system of 3 linear equations in 3 unknowns in this case. No matter in the future, no matter how many equations, no matter how many unknowns, no matter how large the system is, we start from the augmented matrix, and then we perform a list of operations. I told you how to choose the operations. Right? Make leading one of row 1, and then use leading one of row 1 to make these 2 locations 0, and so on. And then leading one of row 2 is here. Use that leading one to make the number below 0, right? And then you go backward. Eventually, the matrix is going to be in REF. After getting a matrix in REF, after getting the matrix in REF, I said the matrix. So because it can be proved REF, the final form is unique. By unique, I mean the different people can perform different operations, but the final form is the same. The final form in REF is all the same. That's what we meant by unique. Okay. By that I mean different people can perform different operations when creating leading one and so on. But the final form, our final form, is always the same, as long as you did everything correctly. Now the solution. After getting the final form, we are ready to have the solution to the system. Anybody want to tell me the solution to the system? Anybody want to tell me the solution to the system?
x1 equal to 1.
Yeah.
1.
x1 equals 1.
Equal to 2.
Again, each row determines an equation. The first row determines the equation x1 equals 1. And then the second row gives you the value of x2. x2 equals 1. And then x3 equals 2. That is the solution to to the system. Actually, this is the case. The system has a unique solution, has one and only one solution.